Okay, this is section 6.4 where we're going to be graphing sine as well as cosine. I'm going to be teaching how to graph these functions by using patterns. That's the approach that I'm going to take rather than making an XY table where you have to do at least like 15 values. That would take way too long. You will be required to produce these graphs by hand, where you can only use the calculator for maybe some calculations of the start point. But you will also have some problems that are multiple choice, and in those particular situations, I'll let you produce the graph by calculator. Okay, so let's get going. A lot of these initial problems you can answer just by looking at the theorem pages where I provided you with the graphs, things of the nature where they're asking you maximum value, domain, minimum values, those sort of things. You can just see them right on the graph. So in the very first problem, they're asking about the sine graph, and they're asking to stay between the x values of 0 and 2 pi and answer the following question. What is the maximum value for this function if you stay between the x values of 0 and 2 pi? Okay, so looking at this picture for sine, we're going to stay between 0 and 2 pi, and they're asking what is the maximum value. So the maximum value occurs at, they want the y value, that's the highest value on the graph. So the answer to that is 1. And then they ask at what x value does that maximum value occur. So this maximum value of 1, which is right here, just follow it down to the x value underneath it. Let me slide this up. This is your maximum value of 1. And then slide down to the x-axis and you will see the x value that corresponds to that maximum value, which is pi over 2. And so that gives you the second answer. Okay, moving on to number 2. Enter the correct choice, completes a sentence. Okay, so they're giving you the function y is equal to negative 3 cosine of 6x, and they want to know what is the amplitude and the period. So first of all, let's look at the theorem page so that you can start getting familiar with that, where to find all the values you need to identify amplitude, period, vertical shift, horizontal shifts, which are called phase shifts when you're doing trigonometric graphing. So here is a periodic function. So I've given it to you right here, and then I've laid out everything for you in written form so that you can have your formulas for anything that you do need a formula for. When you are trying to identify amplitude, that is how tall the waves are, and you might want to add this into your notes, that the amplitude, not only does this tell you that it can be found right out front, so it'll be the coefficient. Now, if you're not given the trigonometric function in this form, then you should write it like this. Trig word first, number out in front of the trig expression will be the amplitude. And then squeezed in between your x variable and coming right after the trig function, you will find what's called the b value. The b value is used to determine period. As you can see here, it is part of a formula for period. By the way, when you are doing sine and cosine, recall from previous sections that sine and cosine have a basic parent period of 2 pi unless they are altered by virtue of their b value. So you're always going to take that parent period and then you're going to divide it by whatever the b value is. Now, if that's just a 1, if there's no number in there, then that means b is 1 and the period remains 2 pi. However, if this b value, again, it comes right after the trig function, but right before the x variable. If that value for b is anything other than 1, then yes, it'll have a different period. I did want to say that with regard to the amplitude, one thing you're going to use it for is you're going to use it for the spacing between what are called the upper, middle, and downward shelves. In other words, the highest, the middle level, and the lowest shelves by which, and these are, just vehicles we're going to use to get the graphs. We're going to use these things called shelves. They're like they're like shelves in a bookcase. So upper, middle, and downward shelf, as well as the middle and the downward shelf. It's also how tall the waves go. Like for instance, when you're looking right here at this graph, notice that, see here, this would be called the middle level right here. This would be called the upper level. Now we're actually going to construct horizontal lines because it'll just make it easier when we're graphing it ourselves from start to finish. So this would be the upward shelf, this would be the middle shelf, and this would be the downward shelf to get to the minimum. And the spacing between here and here is 1. See, it's a distance of 1. That's known as the amp. So it's how tall it is as you reach your maximum, and it's how tall it is as you go down to your minimum as well. We refer to that as the amp. So you can look at it in two different ways. It's the spacing from the middle level to the upward level, in other words, the max, or you could call it the spacing between the middle level and the downward value, which is really the minimum value on the graph. And that's going to be true in every graph. That's what amp means. Okay, going back to period, I can tell you that the period is the distance. It's also called a cycle. Distance it takes to graph 4 points. And these 4 points that we're going to concentrate on will be suggested by the patterns that I'm going to teach you. There's going to be a certain pattern for the sine graph, and there's going to be a certain pattern for the cosine graph. Both of those patterns have 4 different letters in them. Each one is to help you plot a point, because all of these graphs, they are cyclic. The patterns repeat over and over again, and they repeat in a 4-point pattern. So your period is what the distance that you have within which to graph the 4 points suggested by the pattern. I do want to remind you that sometimes you'll have graphs that flip over. They're just going to completely flip over, and that would be if they have a negative out in front as part of the coefficient. And again, this is what you want to write your trig functions in this form with the a value up front. Now, if that a value is negative, that means that the graph is going to entirely flip over. And that was true every time, even when you learned how to graph algebraic graphs back in college algebra. I'm going to show you how to use the patterns that I'm going to teach you, the graphing patterns, how to use those to help you completely flip the graph over. Okay, here's how you know whether or not your graph is going to flip. Again, it has to have a negative out front as part of the coefficient. So that means that you need to recall what we talked about in previous sections. It's come up in section 6.2 and 6.3, the even and odd nature of a trigonometric function. So I was telling you it came about these same properties, that these are the even functions, cosine and secant. So in other words, if they throw you a negative value as your b value, a negative value, in the argument, if they throw you a negative value here, that's just going to come out, and you're going to just be able to get rid of that value. See, whenever you're doing an even function, if they throw you a negative value in the argument, that's called the argument, augment, however you want to pronounce that, it just disappears. For even functions, you can just get rid of the negative, which is what this means right here. You see that it's completely gone. However, when you're doing odd functions, here are two of the odd functions, and these are two of the odd functions. So notice that they've given you a negative in the argument here and here, as well as here and here. So the difference between even functions and odd functions is that for even functions, the negative goes away. So the of a negative function is the same value that you would get as if the negative had not even been there. Same thing for secant, because secant is the reciprocal cousin of cosine. However, with these odd functions, the negative does not go away. It floats out to the front and becomes part of the leading coefficient. Same thing here and here. So you have to memorize which ones are evens so that you'll also be memorizing which ones are odd. And that is the kind of thing that's going to make your graph flip over. But you'll see that as we get to those problems. Okay, the other thing that you have to know how to get here is you have to know how much do you have to slide over horizontally in order to do a graph, and I'm going to speak about that. It's called the jump, and it's going to have to do with the period, but I'm going to lay out all those steps for you when we begin graphing. The typical, though, with your My Math Lab problems is that you're just going to answer some very basic generic questions where you can just kind of look at a graph or do a very simple calculation. So we're going to be doing that for the first 5 or 6 problems, and they get a little bit more complicated, and then I think around problem number 8 we start actually graphing. Okay, so let's continue here. Here's a little bit more information down towards the bottom. The jump is the spacing between each of the 4 points. In other words, the horizontal distance that you're going to move left or right when you go to plot a point. This is the formula for jump. It is the period, whatever you get for the period, divided by 4. Again, you'll see me demonstrating all of these things. This would typically be known, and we'll look up at the equation again, as a horizontal shift. That's what we called it in college algebra. We now call it a phase shift in trigonometry. Okay, so in this particular equation right here, always the number that is with the x in parentheses, that represents, again, what you would have called horizontal shift. And you always need to switch the sign before acting it out in a graph or before telling someone what the horizontal shift is. Again, it's called phase shift. It is now called phase shift. So when they ask you for phase shift, you're looking for this number, like if this was x minus pi, then the phase shift would be positive pi. If it said x plus half a pi, then it would be negative half a pi. You always switch the sign of this C value before reporting what the actual phase shift is. The number that's out here, shh, sorry about that, hold on. Sorry about the noise disturbance. Crazy dogs on the loose. Okay, so this number out here at the end, that's called the vertical shift, and that's going to be a number that makes the graph go up and down. This makes the graph go left or right. Okay, and I'm going to show you how to use all of that, just doing patterns. Everything will be built, will wrap itself right into the pattern. So as we use these patterns that I'm going to be teaching you to graph, you'll be also carrying out the phase shift as well as the vertical shift. It'll all be wrapped into that one pattern. Okay, so let's continue answering the questions now that we've gone over several things here. We've answered number 1. Now let's go look at number 2. Enter the correct choice that completes the sentence. So now that we know a little bit about amplitude and period, we can answer questions that have to do with that. So the amplitude, and by the way, anytime you go to do the amplitude, note that there were absolute value symbols around my definition for amplitude. Amplitude is a distance. It is the distance from the middle level up to the top of the graph, the maximum value, or down to the minimum value. That being said, since it's a distance, it has to be positive. And that's what these absolute value bars mean. Make sure that you're reporting it as a positive. So that applies in this problem. This is called your A value. This is called your B value. The amplitude always comes from the A value. Just take the absolute value, the A value. In other words, get rid of the negative. That's your amp. What is the period? Well, there's a formula for it. It's 2 pi divided case. All generic periods for sine or cosine start off with 2 pi, and then they are altered by whatever the B value is. So ultimately, the period in this problem ends up being reduce these coefficients, the 2 over 6, which is 1/3. So it's 1/3 of a pi. Okay, number 3, decide whether the following statement is true or false. The graphs sine and cosine of x are identical. They are pretty much, with this one slight exception, except for a horizontal shift, and that is true. Let's check out the graphs again, and as you look at this, notice that they both have the same shape, and that's what they mean by they're identical. But the difference is that instead of having a point at 0, 0, that maximum point that is at the x value 0, 0, 1 has slid over to the right, and on this graph, on the sine graph, it appears at pi over 2, 1. So this graph, if you just take it and shift it over horizontally, you end up getting the sine graph. So that makes the problem that we are answering right now true. Okay, moving to number 4. Determine whether the statement is true or false. So you have this function, y is equal to sine of pi times x. The amplitude is 3, that is true. And the period is pi over 2. Well, let's check out what the period is. Period has a formula, and it is always 2 pi divided by whatever the B value is. You need to be good at locating the B value, but in the most simplistic terms, it comes right after the trig function, but right before the x. So this is your B value. That's known as the A value, which helped us answer the question about the amplitude. So if my B value is pi, and the formula for period is 2 pi divided by B, then my period for this particular problem would be 2 pi divided by pi, which is 2. So they say that the period is pi over 2, but yet it really isn't. So this is false. Okay, number 5, decide whether the following statement is true or false. The graph of the sine function has infinitely many x-intercepts. Yes. The graph of the sine function, or the cosine function for that matter, has infinitely many graphs. I mean, they're only showing between negative 2 pi and 2 pi, but that doesn't mean that these graphs don't go on and on. They actually do. So these are some of the x-intercepts that are showing right now, but they actually go on infinitely. Okay, infinitely many x-intercepts, true. Okay, then for number 6, one period for the graph y is equal to sine of omega times x, and y is equal to cosine of omega times x is called a one period, another name for a period, and I think I already verbally said this when I was going over the theorem sheet, is also known as a cycle. Can be referred to in either way. Okay, moving to number 7. Problem number 7, it says y is equal to sine of 3 times sine of 2x. Using the key points, you would want to rewrite this based on your knowledge of odd and even functions. So again, let's go over this again. Sine is an even function, so if they try to throw you a negative in the argument, it floats out to the front. Let's use that to rewrite this problem, because you always want to get rid of the negative in the argument using these even and odd properties, whether it just disappears because it's even, or whether you have to float it to the front because it's an odd function like sine and cosecant, tan and cotan. Either one, get the negative out of there before proceeding with the problem. Okay, so here's your argument. It's that expression right after the trig word. And if you were going to rewrite this, this happens to be an odd function. And for all odd functions, that negative floats out to the front and becomes part of the coefficient. So this is what it would look like rewritten. You're just removing the negative from the argument. Okay, you can still tell what the A value is. You can still tell what the B value is. Okay, so which one does this match? Okay, so you want the -3 out front, and that would leave the argument positive. So this is that answer right there. Number 7. Okay, moving to number 8. And problem number 8. Okay, this one has a lot of parts to it. So just be patient here. This is going to just force you to go over the graph theory that you did a lot of in MAC1105 and will continue to do. So we're going to, look at all these different kind of things like maximum values, minimum values, x-intercepts, questions with respect to the graph. So why don't we take our first shot at actually constructing a graph. Now, whether or not I'm going to have enough room on this actual paper, I could give it a shot, but I think I am going to. I'm going to do it right here. I want you to have a nice big graph so that we can answer these questions. Okay, so here we go. First thing you're going to do is create a y and an x-axis. Again, you need to be able to do these by hand as well as by calculator if I do give you a multiple choice problem. Okay, so the problem that we are graphing is y is equal to, let me just straighten this up, y is equal to 9 cosine x. That's what we've been given in this problem. Okay, so in this order, you are going to identify a bunch of values that we will then transfer to the graph. Okay, first of all, we were talking about how the number out front provides us with the amp. And that is the spacing between what I'm going to call the shelves, like shelves in a bookcase. And you'll see when I install the shelves how we're going to space them out 9 units apart. Okay, so that's what the 9 is. Okay, then we're going to do period. The distance that we have to plot 4 points that come from the pattern, which I haven't mentioned yet. Okay, so the period always starts off for sine and cosine with a 2 pi. It is then altered by virtue of the b value. So in this problem, now right after the trig word, but right in front of the x variable. So there's nothing there. That means that it's a 1. Therefore, your period is 2 pi in this problem. Okay, we have that. We have the 9. Okay, next thing we're going to do is we're going to do the jump. The jump is how often we are going to plot a point within that distance of 2 pi. We have 4 points to plot. And the reason we have 4 points to plot is because every pattern has 4 letters in it. So jump, this is the formula for jump. It's going to be period divided by 4. Okay, so in this particular problem, it's going to be 2 pi. That was our period, following this formula, cut up into 4 parts. Okay, that ends up being pi over 2. So that means we're going to be plotting a point every pi over 2 units. Okay, then next thing that we're going to do is figure out the start point. Okay, the start point, this is how you find the start point. We need to know where to start this graph. So the way that you're going to find the start point is you're going to take the argument. I'll keep pointing out the names of these things. The argument is this expression out in front of the trig word. You're going to take that argument and you're going to set it equal to 0. Now sometimes that argument will be a more complicated expression, like maybe there'll be something subtracted or added. So you'll take that whole thing. If there is more than one item, it'll be in parentheses. And you just set it equal to 0 and solve it if it needs solving. Now, there's nothing I can do here because the minute I set x equal to 0, that x is already isolated. I can't actually go any further. So this is part of your start point. So the start point always begins by you taking whatever the argument is, this expression right here, setting it equal to 0. Then solving it. You will then know the x value of the start point, and all you'll need at that stage is to figure out what is its y partner. For any point, even when you're learning to graph in the lower level classes, the classes that come before this, you just plug in whatever your x value is into the equation and you figure out what the y value is that results. And we're going to continue doing the same thing. In other words, using those basics that we learned when we first started to graph. Okay, so here's the function. Y is equal to 9 cosine of x. Y is equal to 9 cosine of x. We know that our x value is 0. And put that in your calculator. You can also do it in your head. At cosine, the value is 1. 1 times 9 is going to be 9. Now, since it's 0, it's not going to actually matter what mode you're in, but if this was a pi type number, you'd want to put that in radians. If it was degrees, you would want to put it in degrees. You have to tell it what you're feeding in, but 0 is universal. Whether you're talking degrees or radians, 0 is the same. So if you were going to do this, let's see, second quit, let me get out of there. Let me get out of here. Clear. Okay, so let me get back to this screen right here. So anyway, if you want to plug in 9 cosine of 0, which is what I have right here, just go 9 times, call up touch the cosine key, which is right there, cosine, and then put in that 0. And you'll see it'll shoot back a 9 to you. Okay, so this is 9. You now know that the partner that goes with this is 9. So 0, 9. Okay, we're going to put all of this information on the grid now. We're going to do a little graph here. So this pi over 2, this designs the x-axis. Let me write this. I'm invading the space that I have to do my graph. So let me put this right here. This will help you design your x-axis, the jump. Okay, you're going to be jumping in increments of pi over 2. Do not reduce as you lay out your x-axis because then it just makes it harder for you to count. So 1 pi over 2, 2 pi over 2, 3 pi over 2. I mean, if you want to reduce it, you can, but it does make it easier if you don't reduce as you're counting in increments of 1/2. These same numbers will appear on the other side of the axis, the negative side of the axis. Okay, now after you put all these values on the x-axis, you want to try and look at the pattern. So let me suggest the pattern for you. The pattern for cosine is always going to be, there's one pattern for each of these graphs. It's going to be up, middle, down, middle, dum. Okay, that's the pattern that every cosine graph follows. So the way you use this pattern is whatever the first letter is with respect to the start point. So 0, 9 is in the uppermost position. That's what the U stands for. Uppermost position. Okay, I kind of ran off the paper there, but that's what that means. So always look at the first letter. It's all about that start point. So the 0, 9 is in the uppermost position. And that is going to help, knowing that is going to help you install the shelves in your graph. The upper shelf, the middle shelf, and the downward shelf. So go plot 0, 9. Let's just call this 9. So if it goes up to 9, it's also going to be this. Okay, so go plot that point, 0, 9. Install a horizontal shelf, just like a shelf in a bookcase, and call it the uppermost shelf. Then remember I was telling you that the amp dictates the amount of spacing between the shelves. So our amp, notice that our amp was 9. That's this number right here. That means between this shelf and the next one there are 9 units. So drop 9 down, you would be at the x-axis, therefore the x-axis is the middle shelf. So let me see if I can make this a little bit smaller so you can see more of it. Okay, so this will be my upper shelf. And then this will be my middle shelf. You don't have to put it in colors. And then 9 spaces down from that, you're at the downward shelf, or in other words, the lowest shelf. Okay, so there's 3 levels that you're going to be hitting. As you're plotting points, you are not to go above the upper shelf, and you are not to go below the downward shelf. Every time you make your way, because you're going to see that you're going to kind of be moving like a Pac-Man game, if you even know about that game. And so you're going to be coming down, and as soon as you get as low as you can, you'll start on your way up. When you get to the highest level, you'll start on your way down, never breaching the uppermost or the lowest level here. So if I'm up here, that means as I move this way to graph more points, I'm going to start on my way down, and then I'm going to come back up. Okay, so here we go. We're going to use the rest of the pattern now. Right now, I'm at the uppermost point with this point 0, 9, my start point. The jump that I had figured out, the jump of pi over 2, that's how far you're going to slide horizontally as you go to plot each successive point. Okay, so I'm going to slide pi over 2, which is why you need to lay out the numbers on the x-axis so you can easily slide over whatever your jump distance is. So I'm going to slide over pi over 2 from this last point that I just plotted, and I'm going to drop to the level suggested by the pattern. The next letter is M. So I'm going to slide over pi over 2 and plot that point at the middle level. Slide over pi over 2 again, but go to the level that the pattern suggests. You're going to go to the downmost level, so right there. Slide over pi over 2, and now it says that I should go back up to the middle level. Okay, now even at this point, you don't really need to use the pattern anymore. You're always going from top all the way to bottom, always stopping at the middle, in between an upper point and a downward point. So if you were going to do the next point, look, you're on your way up. You've been down, you've been middle, you need to go up. Make sure all your points are spaced out by virtue of the jump. So slide over, you are on your way up, and let's stop there. Okay, then let's do the same thing over here. You're at the top, you need to start coming down, but you always have to have a point at the middle level occurring between your uppermost points and your downmost points. So slide over pi over 2 and drop down to the middle. Slide over pi over 2, drop all the way down. Slide over pi over 2 and start coming back up. Because look here, you were on your way down, but you're as low as you can get, so you have to start coming up. Slide over pi over 2, start coming up. Now you're up at the middle. Slide over pi over 2, go all the way up. Okay, this is your first graph by pattern. Okay, now I'm going to start answering all the questions that they asked for number 8. But now you have a nice spaced out pattern that you can actually answer detailed questions. Okay, so first question says, what is the y-intercept? There it is right there. A y-intercept is a point on the y-axis. That intercept is 9. Okay. Then the next problem is it says for what values of x stay between, make sure you're staying between negative pi and pi, so maybe you want to mark that off on the graph. Between negative pi, here's negative pi, right here, and here's positive pi. We're going to stay between these two x values as dictated by the problem. So the question is, for what values of x, if you stay between negative pi and pi, where is the graph increasing? And if you do not remember this from college algebra, whenever you're answering a question regarding increasing, you use the x values to give this answer, as you can see right here. Maybe you don't understand that they're saying use the x values when you talk about increasing. So first, you have to get eyeballs between negative pi and pi, and I'm going to slide this graph up again. There, so I marked it off for you. And you want to know in that interval between negative pi and pi, where is the graph going up? That's what it means for it to be increasing. That's this area right in here. So this is your increasing portion. It is the only increasing portion if you're staying between negative pi and pi. And when you go to name this increasing portion, you're supposed to be naming the x values at the endpoints of that increasing portion. So here, the x value right here at the endpoint of the increasing portion, that x value is pi. This is the x-axis, so just look right up at the x-axis. Right there at the endpoint of this increasing portion, you have the x value called negative pi. Negative 2 over 2 is negative 1 pi. Then there's this other endpoint of the increasing portion right up here. What is the x value associated with it? Well, drop to the x-axis. That x value associated with that endpoint is 0. So you're going to talk about negative pi and 0 as the x values that go with these two endpoints. So that would be negative pi to 0. Okay, next question, part C. What is the absolute maximum value of the f function, the function that we just graphed? Well, the maximum value is also that y-intercept. Notice that the highest points on this graph don't get any higher than 9. So the answer for that, 9. Okay, for what values this time stay between negative 2 pi and pi, and you can use those endpoints. There's little equal signs here. When does f of x equal 9? That's the same thing as saying when is y equal to 9? For what x values? Keep it between negative 2 pi and positive 2 pi when you tell what x values have a y value of 9. Okay, so let's look at this nice picture again. We're staying between negative 2 pi and positive 2 pi. So when is the function equal to 9? When it has a maximum value of 9. That would be here, right at negative 2 pi. So that's going to be one of our answers. Okay, when else is it positive 9 right here. X value that goes with that, 0. Okay, when else is its 9? Keeping between negative 2 pi and 2 pi and identifying all locations where the y value is 9. So there was one of them, but they wanted the x value that goes with it. Here was another position where y was equal to 9, x value 0, and then here it is again. At 9, that's associated with positive 2 pi. So these are your three answers. These are the x values associated with y values of 9. So negative 2 pi also happens at 0 that you have a y value of 9, and it also happens at 2 pi. Okay, moving to part E. Part E. For what values of x? For what values of x? This time there's no little equal sign right here next to the negative 2 pi. So if one of the answers does happen at negative 2 pi, you're not allowed to give it because there's no equal sign there. If one of the answers occurs at positive 2 pi, you can give it because there's a little equal sign. So this endpoint is not included while this one is. Again, they're asking for what values of x is the y value equal to 9? And where does the y value equal to negative 9? You want the x values that satisfy these conditions. Okay, so we already know that in this particular problem, when we were looking at when is it positive 9, that occurred at negative 2 pi, 0, and 2 pi, but we're not allowed to use this answer this time, again, because there was no little equal sign right here next to the negative 2 pi. So that's out. So when is the y value equal to positive 9 for this value and this value? Okay, we also need to identify when is the y value equal to negative 9. So for negative 9, it occurs right here at negative pi. And then that negative 9 value also occurs at positive pi. So negative pi and positive pi. 2 over 2 is negative 1 pi. Okay. So we'll bring those over here. So obeying this for that, and when is it equal to negative 9, negative pi, and also pi. Okay, for part F. Now part F, you're going to need your calculator. That's going to be the best way to approach this, because then you can use the intersect feature in order to get the actual answer. So for part F, it says, for what numbers between negative 2 pi and 2 pi, again, if any of the answers for this particular problem happen at negative 2 pi, you cannot use it because there's no little equal sign here. If one of the answers occurs at positive 2 pi, then yes, you can use it. Okay, so they want to know for what numbers between here and here, for what x values between negative 2 pi and 2 pi, does the function called 9 cosine of x, when does it equal negative 4.5? This is the same thing as y is equal to negative 4.5. It's easier to put it in as a decimal in your calculator. So basically, they want to know when this graph, 9 cosine of x, is equal to negative 4.5. Like you could put the negative 4.5. The easiest way to do that is to graph this as two separate graphs. This could be one graph. This could be the other graph. This is just a horizontal line, and then you know that this is like a wave. And just look to see where do they intersect. And if you want, and that's the same thing as, as answering the question, when is this equal to negative 4.5? So we're going to use the intersect method on our graphing calculator in order to figure this out. Okay, here we go. Now, if you were to leave this, your graphing calculator, in radians, you're going to get some pretty funky decimals. You're not going to recognize them, and you won't be able to convert them into exact answers. So for this particular, even though we typically graph in radians, I'm going to suggest that for this problem, just because you're looking for points of intersection, leave the mode in degrees. And I'm going to demonstrate on the calculator how to put all of this in. Because then what we can do is we can take our answers and we can convert them into pi, because they do want them in pi form, but you can't just leave your calculator in radian form because you won't be able to recognize them. Okay, let's start by going to where you put in your functions. Okay, one of them is 9 cosine x. Okay, then the next one is y is equal to the other function that we're going to intersect it with is negative 4.5. Negative 4.5. Press enter. Make sure your mode is in degrees, so touch the mode key. Mine's in degrees already, but if it wasn't, you can just move the blinker with these arrows right here until you get on the word degrees, and then press enter. Now quit out of there after you make that selection. Second, quit. Okay, then for graphing trig graphs, Zoom Trig is a pre-made window that will give you a graph, and you will then look at that graph and see if you need to adjust it to maybe see important features on the graph, so, or to give you a complete graph. So let's look at Zoom, where the pre-made windows are. You go to the Zoom key, and they have pre-made windows, but then if you want to adjust the window manually, you touch the window key. So I'm going to go to Zoom Trig, press that. Here we go. Pretty nice graph. The top is cut off. These bottoms are cut off. I would like to kind of see those. I don't know if I'm going to be asked questions about them. So I'm going to adjust manually. Touch the window key. This is the window that just got chosen for us when we chose Zoom Trig. I would like to see a little bit of the more of the y value, so I'm going to let my y min be negative 10. Let the graph go down to negative 10 so I can see the bottoms, and I'm going to let the y max value be 10 so that I can see the tops. I'm just making that bigger. So negative 10. Go down to this one, change it to a 10. Press enter. Second, quit out of there and graph again. Okay, now I can see a nice full graph. Okay. All right, so this line that you see right down here is negative 4.5. That is the x-axis. You have a maximum height of 9. You have a minimum height of negative 9. Remember, this one is the negative 4.5. And that one's just the x-axis. So now we're going to answer the questions that they have. And the question is basically, when are these two graphs equal? The negative 4.5 and the 9 cosine of x. Well, that would be where they intersect. Notice that they intersect here, 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 and here. So there's 4 different answers you should be giving, and you're going to use the intersect feature of your graphing calculator to get those answers. We will be getting the answers in degrees, but then we will convert them to pi form. Okay, so here's how to get the intersection points. Just go second, calculate, and let's write these steps down. To get intersection points, you're going to push second, calculate. That's what I pushed so far. And then you're going to arrow down to the intersect feature and press enter. Okay, arrow down to intersect and then press enter. continue with that. So now it's going to start to ask you some questions. Notice that the blinker is right up here. I want to go after this point right here, where the first point. Remember, the points of intersection are here, 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 and here. So you're going to get yourself over here to this first one, and we will find them moving to the right. To make this blinker step over to where you want, you need to use the sideways arrows, not the up-down arrows, because that'll make it jump off the graph. Okay, I want to come to the left, so I'm going to use the left arrow. Just keep your finger depressed and it'll move much more quickly. Get yourself over by that first intersection point. Okay, there it is. It's still on the curve, and is the blinker on the first curve? That just means, is it on one of the curves that you're trying to focus in on? Yes, it is. So when you want to tell your calculator, yes, the blinker's on one of the curves that I'm interested in, use the enter key to say yes. So enter. Then the next question will say, is the blinker now on the other curve? That's what it means. Is it on the second curve? Yes, that blinker is on the straight line now. That is the other graph I'm interested in intersecting with. So I'm going to say yes. Then it'll say, would you like me to guess at the intersection point? Yes, I would. Press enter again, and there you go. Negative 240 degrees is one of the answers. Okay, now we're going to go after the next one. Okay, every time you get ready to get another answer, you have to clear the plate. You have to clear the answers that are in here right now. So you're going to push second calculate again. That'll allow you to start over and find any intersection point you want. Okay, now we're going to move over this way. So use sideways arrow to the right. It'll say, am I on the curve? You can be on the curve below the 4.5 line, or you can be above it. It doesn't matter. Even this would have been good. So am I on the first curve, one of the curves? Yes. Now it says, am I on the other curve? Yes. Would you like me to guess? Yes. So this next answer is negative 120 degrees. Now, you're going to see when we look at this graph is symmetric. Notice that everything that's going on the left side of the y-axis is also going on over here. In other words, it comes down, minimizes, and then goes up. That's the same exact thing that's happening here. It comes down, minimizes, goes up. So this graph is symmetric with respect to the y-axis, mirror images on either side. That means something with respect to the next two answers. I mean, if you had knowledge of symmetry, then you would know that if the same thing is happening on either side of the y-axis, then you're going to get the same two answers on the other side of the y-axis, only they're going to be positive. You'd have a positive 120, that would be the next answer, and you would have a positive 240. I mean, you can prove it to yourself on the graph by just going after the next one. Just pressing second, calculate again, going down to intersect, and then just moving over to that area, over to the area of the next answer with the sideways arrow to the right. There I am right next to the next answer. I am on the first curve, and I'm going to press enter. Then it says, are you on the second curve? That means the horizontal line. Yes. Guess at it? Yes. You see, there you go. Same as one of the answers that we had over on the other side of the y-axis. It's the 120. And so if you do the fourth one, you're going to get positive 240, positive version of this answer. Okay. So if you're going to change these to pi form, why don't you just change one of the positive ones and you'll know what the negative counterpart is. So this will be 120. This is 180 is equivalent to pi. So be 120 pi over 180. Reduce that. Of course, the zeros cancel. 6 goes into the top twice, 6 goes into the bottom 3 times. So this is 2/3 of a pi. You could go and convert the 240 also, but this is just double this. So if this one is 2/3 pi, then this one would be 4/3 pi. If you're going to double something, you don't double the denominator, you double the numerator. Instead of a 2, it would be a 4, if you don't want to go through this conversion process. These answers are going to match these, only they have negatives. So this would be the 2/3, and this would be the 4/3. Okay, and those are all the answers. So a little bit of calculator technology to get to those answers. So this is negative 4/3 pi, negative 2/3 pi, positive 2/3 pi, and positive 4/3 pi. Okay, and that completes that answer. Okay, what are the x-intercepts? Okay, x-intercepts, again, let's look at our picture, which can give us almost all the answers that we got, except for number 8. We needed a little bit more help from the calculator there. Okay, so the x-intercepts happen at, and let's see what they're telling us to stay in between. What are the x-x? We want to choose also the formula that will get those x-intercepts. So let's identify the x-intercepts first. Okay, so the x-intercepts are, okay, let's see, negative 3/2 pi, negative 1/2 pi. Okay, those are the ones on the negative side. And then here's another x-intercept. And, you know, again, this is symmetric. So if negative 3/2 and negative 1/2 were over here, then you're going to have positive 1/2 and positive 3/2. All right, now what we want to do is figure out what is the formula given that k can be any integer. Okay, all of these formulas have a k in it. If k can be any integer, then you need to remember what integers are. They can be anything like this. 0 is an integer, positive 1, positive 2, on and on and on. Now I'm just going to mess with the positive integers and make sure I can find the formula, because there's no sense making it harder than it needs to be by trying the negative ones. So the only possible answers it could be is either this one or this one. I know that because look at all these answers. They all have denominators of 2. Therefore, the formula has to have a denominator of 2. Now, if you plug in any of these integers, like I would consider plugging in at least the 0 and the 1, would you get the answers that you've already seen being the x-intercepts? We need to pick the formula that would generate these values that you see right here, knowing that the k values are integers. So let's see. I'm going to try this one first. But you could try either one until you find the one that's giving these answers. Okay, if I put a 0 in there, that would be 2 times 0 is 0. 0 take away 1 would be negative 1/2 pi. That is one of the x-intercepts. I'm good so far. Let's try at least one other number. If both of these work, you know that that's the formula rather than that one, so then don't bother using the other one. So let me try the 1. If I put a 1 in here, it would be 2 times 1 is 2. 2 take away 1 would be positive 1/2 pi. And yes, we do also have a positive 1/2 pi. So trying the 0 gave me this answer, trying the 1 gave me this answer, and again, if 2 of the answers are coming out right, that's the formula. So this is the formula that goes with that. Okay, so a painful problem at best, lots and lots of parts. Although it's kind of fun to review all of the graph theory that you're going to be using as you do these problems. Okay, so getting more into doing these graphs. Next graph is number 9. It is y is equal to -4 sine of 2x with a flip. You're going to be flipping this graph over the x-axis. So first thing I want to tell you is that when you're doing these problems, that you have to consider what is the basic pattern that goes with that particular type of function. So I had done one already by hand, which was the cosine function, and that was up, middle, down, middle. That was the pattern. I'm done. The pattern for sine is MUMD. That's without the flip. That's without the flip. So let me show you how you flip it. So flipped, the pattern would now look like this. All you do is you concentrate on the letters U and D because you are going to switch those letters. Up will become down, and down is going to become up. So flipped, the pattern will look like this. The middle can't change. Middle is middle no matter what. Okay, this will take the entire graph and flip it over. So it is this pattern that you want to use to graph this particular problem. So that takes care of the negative for you. Now we go about the business of getting the whole graph to occur. So let's go to that. Okay, I think I'll have a little more room if I just do it right here. Okay, so here's my y-axis. Here's my x-axis. Okay, let me lay out all the steps for you as I did before. The amp. Remember, amp's always positive, so it's just positive 4. It comes from the A value, taking the absolute value. Period. Period always starts with 2 pi, but then is altered by whatever the B value is. This is your B value. That was your A value. The A value helps you get the amp. The B value helps you get the period. So my B value is 2, therefore my period is 1 pi. Then you're going to get the jump. These will design the grid mark spacing on your x-axis. I'm going to put that right here, that you use that to design the x-axis. Okay, so the jump is going to always be, here's the formula, period divided into 4 parts. So period divided into 4 parts is pi over 4, and you can go ahead and design your x-axis. I don't know if you want to, I would not reduce as you go along. It'll just be easier to count out the grid marks. Okay, and I'm going to put those same grid marks here. All right, and then we're going to do the start point. Okay, the start point. You're going to take the argument. Now let me write the original problem. It was y is equal to -4 sine of 2x. Let me continue pointing out the argument. It is this expression right here, right after the trig word, the entire expression. You're going to start off by setting that equal to 0, then solving it to get the x coordinate at the start point. Okay, so if you were to divide by 2, you still get x equal to 0. So your start point has an x coordinate of 0. You need to now know what the y coordinate is that goes with it. So you can take the function and just plug in a 0 for x. So 2 times 0 is just sine of 0. And if you know how to do that value in your head, fine. Don't use the calculator. Sine at 0 is 0. 0 times -4 is 0. But yes, again, you can just put it in your calculator. You can just enter exactly this, -4 times sine of 0. So the negative is down here at the bottom, right there, when you have a leading negative. So -4. Whoops, I turned it on. That would help. So -4 sine of 0. Close that up. Press it. See, you get a 0. When I was doing it, I was thinking about the unit circle, that if you were at 0 degrees on a unit circle, the sine value would be 0. In other words, your y value would be 0 times -4. But again, you could get your calculator to help you. So that means we're going to start at 0, 0. We need to know the pattern we're using, because the pattern we're using, remember, this was flipped. This thing was flipped, and there's the flipped pattern. So that's the one you want to put on your paper, MD, MU, and remember that the first letter of the pattern is with respect to the start point. So that start point is at the middle level. Right there is the start point, labeled at the middle level. And then we're going to do the spacing to get the other shelves, the upper level and the downward level. I refer to them as shelves. Okay, so the spacing is 4. So we're going to go 4 units up. And this will be my upper shelf or upper level. And then go 4 units down from the middle. And that'll be my downward shelf. Okay, if you want to put them in different colors, you can, just so they stick out, but not necessary. Okay, so we've already done the first point at the middle level, so therefore to continue using this pattern, we are next moving to down, then middle, then up. We have this point, now we're going to go down. Remember, when you go to plot a point, you always have to slide over whatever the jump is, which is why we labeled the x-axis with this jump value. So we're going to go over 1/4 and down to the downward level suggested by the pattern to plot the point. Then we're going to slide over 1/4 again, back up to the middle level, which is the next letter suggested in the pattern. Then we're going to slide over 1/4 again and go to the uppermost level, so says the pattern. You can connect some of the points at this stage. Okay, and if you want to do one more point, just slide. You have to start coming down. You always have to stop in the middle before going here. You can't go directly from the upper shelf to the downward shelf. So slide over in the middle, you're on your way up. I made that a little bit too curvy. Okay, so if you're on your way up, you know you have to slide over 1/4 and then you can go all the way up. Then you have to slide over 1/4, start coming down. You are at the upper shelf, start coming down. Keep going down, but always slide over 1/4. You're at as low as you can get when you get to this blue line, the downward shelf, so start going up. This will be the rest of it. Okay, so now let's see. In this particular problem, I just wanted to show you how to get the graphs. I wanted to show you what one of those flips looked like. All they asked you for was the amp and the period. But just to give you more experience with these graphs, I did the whole thing. The period is 1 pi. Okay, so now I've done a sine and a cosine graph, but I did for the sine graph one with a flip. Okay, here we'll just answer the question. The amplitude is the number out front, but in its positive form, because it's a distance. For the function, what's the period? Sometimes they call the period t. So the period is going to be, again, here's the formula, 2 pi divided by b. So that's going to be 2 pi. Remember, this is the a value, the coefficient of the trig function, and then this is the b value found after the trig word but before the x. So this is going to be 5/4. Then if you want to simplify this complex fraction, you leave the top as is, float the 5/4 up to the same level as the 2 pi, but multiply by the reciprocal rather than the actual fraction you have here. Dividing, which is what's happening here, this says 2 pi divided by 5/4, is the same thing as multiplying by the reciprocal of the denominator. This becomes 8 pi divided by 5. So that period, that's the answer, 8. So I don't really need to write it over again. Okay, that's your answer right there. Okay, number 11. Okay, number 11 says graph. So we're graphing a regular sine function, no flip here. I mean, and if we do decide that we're going to use the grid marks that we have right here, that's what I don't like. I think you can change those. But anyway, the way you're doing it in MyMathLab is you're just picking the graphing tool that you need. When you hover over the two shapes that we are graphing in this particular section, it'll light up with the word cosine or sine as you hover over the graphing tool. So you'll know to pick the right one. And I think all you have to do is pick one point that's on the graph, and then you answer some questions below with regard to, does it have a phase shift, what's the amp, those kind of things, in order for it to fine-tune the graph for you. So because you're letting MyMathLab, the actual graphing calculator, do the whole thing for you, you're just basically answering questions. All you need to do is pick which shape it is, and as I said, there's only two to choose from, and when you hover over each one, it'll say whether it's the cosine or the sine wave. And then you need to click on one point that's on the graph. So you're going to be doing these by hand, since you have to do them by hand, and that's going to be, you know, a lot of stuff to remember for you. So practice them by hand and then use that graph in order to get the graph in MyMathLab. So I'm going to do this one by hand. I'm going to do whatever I need to do for the grid mark values that they've given me here. Okay, so let me do my calculations below. So the amp for this particular problem, I have a little room to do it here, is 2. The period is 2 pi divided by b. So it's just going to be 2 pi divided by 1, just 2 pi. The jump, the period divided into 4 parts. So it's 2 pi divided by 4, which is pi over 2. Okay, start point. You take the argument, which is just x, set it equal to 0, and that gives you, solve it if you need to, but this is already solved. And you get the x coordinate of the start point. Then to look for the y partner, you just use the equation. Y is equal to 2 times sine of x. The x value at the point you're looking for has an x value of 0, so put that in there. So you can put this right in your calculator, but you will get 0. Okay, so you're going to be starting at 0, 0. Get the pattern out. Now this pattern is going to be the regular sign pattern without a flip because there's no negative out there. That basic pattern is mum D, and the first letter is all about your start point. Your start point is at the middle level. Okay, so right there, start point, middle level. The jump is pi over 2. So I think I am going to, I mean, you could stick with what you have here. Just that you're only going to be plotting a point every pi over 2 units. If you want, you could call this half a pi. Then this would be 2/2 pi. Yeah, I like to just label these myself. 2/2 pi. Then this would be 3/2 pi, and this would be 4/2 pi. So 1/2, 2/2. I'm labeling these every 2 grid marks. When I'm doing it myself, I use 1 grid mark for every jump, so it's easier. They have here. So same thing here. If this is 1/2 pi, if this is 1 pi, -1 pi, then this would be half of a pi. And if this is 1 pi, then this would be 1.5 pi, also known as 3/2. I can make this sort of clearer. So it's legible. Okay. And you can label this one too if you want to. That would be 2/2. Okay, so all right, so anyway, now when we go to do this problem, okay, we're going to start putting the rest of the values on here. We know that the start point was at the middle level. We can install the rest of the shelves, and the rest of the shelves would be spaced by the amp. So the amp is going to be 2 units up, 1, 2. This will be our upper shelf. And then 2 units down from the middle will be our downward shelf. Okay, you can put colors in if you want to. And now use the rest of the pattern. So we are using mum D in order to do the rest of it. I'll put it right here, the pattern, so that you can just refer to it. So you can see it while I'm graphing. Okay, so here I already did the one at the middle, so now I'm going to go up, and remember I am sliding over a distance of pi over 2. So slide over pi over 2 and go to the upper level, so says the pattern, and plot a point. Then slide over pi over 2. Okay, I was at 1/2, now I'm at 2/2. So slide over pi over 2, pattern says go back down to the middle level. Then slide over another 1 pi over 2, and the pattern says that you should plot a point at the downward level. So right there. So here we go, we have part of the graph right over here. Okay, then if you want to get some of the graph over here, then again, just slide over 1 pi over 2. And you can just tell, you don't need to look at the pattern anymore. You were at the top, you were at the middle, only place you can go is down. Slide over pi over 2, start on your way back up. You're at the lowest level, you have to start going up. You were at downward, middle, upper. Always slide over pi over 2. You can get more of the graph this way. Okay. So that's one right there. All right, now let's see, what else are we being asked here? Use the graph to determine the domain. Type your answer in interval notation. Okay, so for this particular problem, okay, 1 second. Let me look at something that was. Yeah, okay, so let me see, what else? We only have to do domain and we also have to do range. Now for this particular graph, sine and cosine, unless they restrict your domain in the instructions, it goes on to infinity. This graph actually goes on and on and on to the left, and it goes on and on and on to the right. So you could, you can even bring another point right down here. But anyway, this goes on and on. This goes on and on. So the domain is just how wide is the graph. It's about your x values. Okay, then use the graph to determine the range. That's how high and how low does it go with respect to the y values. This is how wide it is. This is how high and how low it goes when you're doing range. It goes as high as 2 and as low as -2. So if you're going to answer an interval notation, one of the rules for interval notation is that you always say the smaller value of the two that you're going to mention. -2 and 2. -2 is the smaller one, and +2 is the bigger one. You have to name the smaller one first. Okay, that's number 11. Get rid of this. Okay, moving to number 12. Okay, so number 12. Okay, number 12. Graph the following function, domain, range. Okay. All right, so here we go again. We're going to be doing sine with a flip. Okay, so sine with a flip. I'm going to do as much of this as I can. I'm just going to squeeze it in here. So the amp is 5. The period is 2 pi divided by the b value, which is 1, so just 2 pi. The jump is whatever your period is divided by 4. So your jump is 2 pi. That was my period. Cut into 4 parts is pi over 2. Okay, we're going to use that to label the x-axis. So this is pretty nicely laid out. We're going to be jumping every pi over 2 unit. So I'll let this be 1/2 pi because this is 2/2 pi. This is 3/2 pi. And this is 4/2 pi. Same thing over here, but with negatives. 1/2 pi. This is 2/2 pi. This is -3/2 pi. And this is -4/2 pi. Start point. I didn't do the start point yet, so just take the argument when you're doing the start point and set it equal to 0 so that you'll have the x coordinate. Then, as you've seen me do in other problems, if you want the y partner, then use the function that starts with y, and that will allow you to get the other value. So it would just be -5 times sine of whatever the x value is at the start point, which is 0. And you could go ahead and put that in your calculator as we have in previous problems, but sine of 0 is 0, so times -5 is still going to be 0. So you have a start point at 0 again. Then you have to recognize that the pattern for a sine function without a flip is mum-d. So if you're going to flip it, you're going to switch the u to d, and you're going to switch the d to u, so that it would be md mu. That's the pattern that you're using, md mu. Okay, so now putting the start point in there and realizing that the first letter of the pattern refers to the start point. So we know that this is the middle. And then we can put the other levels in there just by using the amp. The amp's at 5. So right here at 5, between 4 and 6, you have your upper level. And then right here at -5, you have your downward level. And then you just go ahead and use the pattern to get the rest of the points. Okay, so we already did this first point at the middle level, the 0, 0. Now we're going to go downward, go to the down shelf, the most downward shelf, jumping pi over 2, plotting on the downward shelf. Then move over pi over 2 again and come back up to the middle. And then move over pi over 2 again and go all the way up to the top. And you can go ahead and connect those. Okay, then get some points going on over here. So you're on your way up here. You were at middle, up, now you're going to go to the top. Space it out, pi over 2, and continue on your way to the top. Okay, now start coming down. Jump horizontally, pi over 2, down to the middle. Jump over pi over 2, all the way down. And you can do one more if you want to, just like you can do one more here if you want. Okay, remember these graphs go on indefinitely. Go like this, like this. This would have been another point if you were going back up. And then answer the questions about domain. Again, domain is how far to the left does the graph go and how far to the right does it go. In other words, the width of the graph. Domain refers to the x values that are on the graph. So anything from -infinity to infinity. Use the graph to determine the range. Well, it goes as high as 5 and as low as -5. So 5 to 5. Okay, and that completes that graph. Number 13. Graph the following function. Show at least 2 cycles. Use the graph to determine the domain and the range of the function. Okay, so let's go ahead and do this one. The amp is 1. Okay, the period is 2 pi divided by the b value. This is your b value. The 1 is your a value, which signifies the amp. So 2 pi divided by b, when the b value is 6, would give you a period of 1/3 pi. Okay, the jump is always the period cut into 4 parts. So here's the period divided into 4 parts. So the way you could do this is when you're doing division with a fraction, the numerator stays the same. And then the divisor you multiply by the reciprocal. So that would give you a jump of pi over 12. All right, then let's see, what else? The start point. Let's do the start point. Start point. You just take the argument, which is 6x, set it equal to 0, and solve it. Divide by 6, divide by 6, you would still get a 0. So the x coordinate is 0. The y partner, we can do that right here. You just go y is equal to cosine of 6 times 0, which is just cosine of 0. Okay, so cosine of 0 is 1. But again, put it in your calculator if you don't know that. It can be, the mode can be in degrees or radians. So your y value is 1. Okay, so we have this, and we are obeying the pattern dum. That's the pattern for cosine without a flip. So that this start point of 0, 1 Don't forget, that's with respect to the first letter of the pattern. So that start point is in the uppermost position. Okay, so let's go plot that. 0, 1. You're at the uppermost level. Okay, and knowing just one of the levels, in other words, the start point allows you to know one of the levels, you can put the other two levels in place. If this is the uppermost level, the other two levels are below it, and they are spaced out by virtue of the amp. So this is going to be the next one space down. That's going to be your middle level. Because it has such a small amp, it's going to be a very tiny graph. And then down here at -1 would be the whole graph is going to be squeezed in between those three lines right there. Now, as far as your x-axis and this jump of pi over 12s, I wouldn't use their numbering for this because it's just going to make it too scrunched in together. So I would just actually count each one of these as pi over 12. And I wouldn't label every single one. So that'll be 1/12, this will be 2/12, this will be 3/12. I would not reduce if I was you. That'll be 4/12. This will be, I would just get rid of their numbering because you don't need it when you're doing the graphs anyway. When you go to put the graphs in MyMathLab, that you, like I said, you're picking the graphing tool, and then you're answering questions. You're picking one point on the graph, which you're going to know from your graph that you created by hand. And then you're answering questions at the bottom, like, is there a phase shift, and what's the amp, and things like that. And that's how MyMathLab fine-tunes your graph. So these numbers on the x-axis are not so important unless you're going to, and they're going to be as precise as you need them in your graph that you're creating by hand. So this would be, that's 1/12 right there, that first one, 3/12, 5/12, 6/12, this would be 7/12. I don't think I'm going to go any further than that. This would be -1/12. 2/12, 3/12, very tiny graph, so kind of annoying to put these numbers on. 4/12, 5/12, 6/12, 7/12. Okay, so now start graphing. We already have this first point, which is at 0, 1. Then we're going to go over 1/12. Each grid mark stands for 1/12, which is our jump. We're going to slide over 1/12 and do what the pattern says. We were already at the upper level, now we're going to the middle level. Getting another point right there. Slide over 1/12, go to the downward level. Slide over 1/12, back up to the middle. And then you can let go of the pattern from there because you can see the way that you're moving. You went down to the middle, down to the bottom, up to the middle, all the way up, always sliding over 1/12. Slide over 1/12, start to come down. Slide over 1/12, all the way down. Slide over 1/12, back up to the middle. Okay, same thing here. Start to come down. Then slide over 1/12, all the way down. Slide over 1/12, back up to the middle. Slide over 1/12, all the way up. Slide over 1/12, back to the middle. Slide over 1/12, all the way down. Okay, and there is that graph. Okay, use domain. The domain here is -infinity to infinity, as it has been for the other graphs. It goes on and on and on. And then the range, it goes as high as 1 and as low as -1. Okay, then 14. Graph the following functions. Select show at least 2 cycles. And That means, you know, whatever the period is, show twice as much of that. Use the graph to determine the day and range, same thing. Okay, so for this particular one, okay, so now we need to start thinking about odd and even functions. So this is an odd function. The negative comes out of the argument in the following manner. It doesn't completely go away. It comes out and becomes the coefficient. Therefore, you are graphing y is equal to negative sine of 4x. And because you're graphing this with a negative that's out in the front as a coefficient, that means you're going to use the flipped over pattern. So once again, this is the regular pattern for sine, mum-d. The flipped pattern would be switching the u's to d's and the d's to u. That is what you're going to be using to make it flip over. Okay, the amp. Amp is 1 for this problem. Period is 2 pi divided by b. So 2 pi, that's your b value right there. So your period is going to be pi over 2. You use the period to get the jump. The jump is the period divided into 4 parts. That's the formula for jump. 4 parts meaning you're going to plot 4 points because the pattern has 4 letters within that period. So take your period, which is pi over 2, divide by 4, which is the same thing as taking pi over 2 and multiplying by the reciprocal. So instead of dividing by 4, you're multiplying by the reciprocal of 4, which is 1/4. Okay, so the jump ends up being pi over 8. Again, I'm not going to use these. I'm going to put my own numbering system on here just to make it easier. So every grid mark is going to be pi over 8. 1/8. We have 2/8, so we have 3/8, and we have 4/8. So this goes from pi over 8 to half a pi. And then since we're supposed to be showing 2 periods, that's 1 period right there. We'll show some of this on the other side. So negative 1/8, negative 2/8, negative 3/8, and negative 4/8. So we have another cycle over here. Okay, then as far as the start point goes, the start point is when you just take the argument, which is negative 4x, or you can use it like this. You've already rewritten it, so just keep referring to this actual function where you pulled the negative out into the front. So the argument would now be, not that you would get a different start point anyway, even if you did use the negative. Take that argument, set it equal to 0, divide by 4, you still get 0. Use that x value in the original function, or the function where you've rewritten it rather, even though again you'd get the same answer, putting in the 0 for x. So you're letting your calculator, or you can do it in your head, what is the sine of 0 multiplied by negative 1? It is still 0. So your start point is 0, 0. Okay, so put that start point in. Again, recognize the pattern. This is the flipped pattern. Okay, and then in the flipped pattern, this M is the first letter. That means 0, 0 is at the middle level. So this is the middle level. And then use the amp to establish the upper and downward levels. So the amp is 1. So again, very tiny, short graph. This is going to be the upper level. Let me move this down a little bit. And then -1 right here is going to be the downward level. Okay, so then putting these points in place. Okay, finishing with this pattern, we're going to go from this first point that was at the middle level, and we're going to do what the pattern says. We're going to the downward level. So typically this graph would go from middle to up, but because we flipped over, we're going middle to down, and that makes it flip over. So the next point is going to be move over pi over 8, go to the downward shelf. Move over pi over 8, back up to the middle. Move over pi over 8 and go to the upward shelf. And then you can do, you know, another point. You're up at the top, so go over pi over 8, drop back down to the middle. You connect these, it goes like this, like that. Okay, so here you were on your way back up. You were at the bottom shelf, the middle shelf. Now you're going to the upper shelf. So move over pi over 8, go to the upper shelf. Okay, then start coming down. So you're going to start coming down, hitting the middle level first. I've moved pi over 8. Then I'm going to move pi over 8 again and go all the way to the bottom shelf, which is right there. And then I'd be going up at that point. So I'd be going up, that would be right there. Okay, let's make sure this is down, middle, up, middle. And this one is, I was at the downward, then I went to the middle, then I went up, then I went back down to the middle, down, up. Okay, so use your graph to establish the domain. Again, the domain is these x values would go infinitely to the left, infinitely to the right. So that's -infinity to infinity. And the range goes as high as 1 and as low as -1. Okay, and that is number 14. And I need to make a little correction on these ranges that I did. When you do the range, you actually have a point on +1, and you actually have a point on -1. So these really need to be brackets rather than parentheses. And let me fix that anywhere else that they actually asked for. Domain and range, if I can find those problems. Okay, so I believe in 8, so that was number 8. Okay, so in number 9, let's see where else they asked for this. Okay, so in number 11, same thing, same comment here. You actually had a point on 2, actually had points on -2. So this needs to be brackets, because my math lab will mark you wrong even on that. Okay, that was number 11. I think number 12, we also did a graph. So let's look for that range answer. That range answer for number 12 should have brackets around it also. And then in number 13, brackets around the range answer as well. Okay, so a little correction on that. Just for the range, make sure you have brackets. You can't put brackets when you're talking about infinity because there's no value that you're actually stopping at, whereas here there are. The infinity symbols always have the parentheses around them. Okay, so I got all the way to number 14, did the domain and the range, the graph, and then problem number 15, we get to a problem that only has a vertical shift. Notice that this number is not encased in parentheses with the x, therefore it's a vertical shift. If it was part of what we call the shift, what used to be known as horizontal shift, that would all be in parentheses, and you would switch the sign before saying what the horizontal or the phase shift is. Okay, so in this particular problem, again, all of these flips and vertical shifts and phase shifts, they all get carried right into the pattern. So just do it as before. Amp is 2. Then the period is 2 pi divided by the b value. Again, the b value is always right in there after the trig word, but before the x, which is 1, so it's just 2 pi. And then the jump is going to be the period divided into 4 parts, which is pi over 2. Okay, so we're going to do our x-axis in increments of pi over 2. Okay, so I think I'm going, just to make this easier, I'm going to call this pi over 2. 1 pi over 2, this will be 2 pi over 2, this will be 3 pi over 2, this will be 4 pi over 2. This will be negative 1 pi over 2, this will be 2 pi over 2, 3 pi over 2, 4 pi over 2. So it's just easier to use the jump to represent each grid mark. Okay, so then we have the jump. We also have to do the start point. The start point, we're taking, move this over a little bit, that's my vertical shift. So for the start point, you're taking the argument, which is just x. That's not part of it. That's the argument, and you're just setting it equal to 0. That gives you the x coordinate of your start point. And then for the y partner, you're just going 2 times cosine of that x value, I'm just using this function, plus 1. And if you put that in your calculator, you're going to get a 3. But we'll do that together. So the start point is going to be at 0, 3. Let's just practice doing it together. So we were going to do 2 times cosine of 0, add 1, and you get 3. And that's because cosine of 0 is at 0 degrees, the cosine is 1. Times 2 is 2. 2 plus 1, 3. If you're doing it in your head, some of you are going to be doing it in your head. Okay, so we have 0, 3 as our start point. Pattern for cosine is dum, up, middle, down, middle. And remember, this very first letter speaks to the start point. So at 0, 3, we're going to be right here. 0, 3 is at the uppermost level. So that's our upper level. Then if you space out the shelves by way of the amp is 2, then you'll have the rest of the shelves. So the downward shelf is going to be 2 spaces down. So drop down right there. And again, you're seeing that this middle level is no longer at the x-axis, and that's because it has a vertical shift. That means all the levels shift up 1 unit. Notice that the vertical shift is positive 1. So where the middle level used to be here, it is shifting up 1 unit, and that makes all the rest of the shelves, like the upper shelf and the downward shelf, it makes all of them shift up 1 unit. So like I said, this pattern will wrap all of the changes right into the graph. Okay, if you space it out 2 more units, 1, 2, you will be at this downward shelf. There's all your shelves, and then you continue plotting. We already have 1 point. at the upper point. Now we're going to go to the middle. So we're coming down now. We're going to go to the middle, spacing it out pi over 2 between the points. So over pi over 2, middle. Over pi over 2, all the way down, says the pattern. Over pi over 2, back up to the middle, and if you want to keep going to catch this other point, over pi over 2, and you would be back up to the top. I mean, when you run out of letters, you can just go right back to the beginning, or you could just realize that, hey, if I'm at as low as I can be, I have to start going up, and once I get to the highest point, I have to start coming down. Then you don't need to look at the pattern once you have a few points in place, because you already can see the way it's moving. Okay, like then that's what I'm going to do over here. I'm already at the top. I have to start coming down. Move over pi over 2, drop to the middle first, then go over pi over 2, then you can go all the way to the bottom. You always have to stop at the middle and plot a point when you're on your way down. Same thing when you're on your way up. Over pi over 2, stop at the middle first, over pi over 2, then you can go all the way up. And then you can just connect these. Okay, use the graph to type the domain. Again, this graph goes on indefinitely to the left and the right, so that's negative infinity to infinity, and then the range. Remember, we need those brackets. I made that comment to correct those symbols when you are trying to give the range. It actually hits at, let's see, what is this, 3? It hits at 3, so that's the maximum value, and it goes as low as -1. Okay, so now you have also the domain and the range. Okay, so the rest of the problems are in other videos that are in your Blackboard shell that completes numbers 1 through 14. Sorry the video is long, but there's lots of details that go into this graph that I have to discuss with you. Okay, that's it.